All right, so the Ultraprobe 15,000 reimagined and its applications. So it's not only the tool, but it is also what can we do with it, right? And ultrasound is a very nice technology because what we can do with it is when we do our inspections, and you see me now, I also have headphones on, Bluetooth in this one that I use for the webinar, but the Ultraprobe or the ultrasound instruments also use headphones. So when we touch, we hear. So basically, the equipment wants to tell us something, and the Ultraprobe makes it possible that we can hear what's going on. Okay, so at UE Systems, we believe everyone has the right to work in a safe, reliable, and efficient plant. Of course, that's a very general saying, but we can participate or we can add a little in that safe, reliable, and efficient plant. Because reliability, that's all got to do with collecting data of our assets. And with ultrasound, we can collect data from our assets. It's one of the technologies, but absolutely. So the more inspections we do, the more we understand how ultrasound can be a benefit in our industrial environment, the more effective the plant will be and safe, of course. So just a simple overview. All the feedback we get from our customers or our users will eventually be used to develop new products. So we constantly develop innovative new products. So if you have a remark about one of our products, feel free to give me your remarks, your comments, because you are the users. You will see things what we cannot see. So the customer excellence is key in this situation. The better the users, the more feedback we have, the more effective our products will be in the future. And this is one of our innovative new products, what eventually is going to be launched on the market. It's a pilot project, what we are running now in the US and in the UK. But if this is going to work, it's a wireless online monitoring and lubrication system. So that is something what we are working up on already for a while now. So, all right, before I'm going to explain you more about the world of ultrasound, of course, it's always easy like, hey, who's that guy sitting in front of his computer telling something about ultrasound, telling something about UP 15,000? My name is Peter. Worked 13 years for UE Systems Europe. My headquarters is based in Almelo, and I am the product manager of UE Systems Europe. That means I'm really involved in product development, finding the new technologies, getting the know-how of existing technologies and becoming a specialist. So everything what's related to products, well, that's my portfolio. Okay, so UE Systems itself, 1973, founded in New York, Elmsford. So that means we already have 50 years experience in the world of ultrasound. And the two main parts what we still use ultrasound for is energy conservation, so saving energy, and of course, predictive maintenance. And predictive maintenance, that is growing and growing and growing and growing. Okay, so we are an American company. We have several headquarters, one for Europe, that is in the Netherlands, and we are market leader for the ultrasound instruments. We are continuously busy with developing products, software, by the feedback also what we get from our customers, and to make the software better if needed. We do different kinds of training support. We do certified courses to Cat 1, Cat 2 of ultrasound. We do equipment training. We do implementation training, one day on site, training at our office, boot camps, basically every type of support or training. Well, we can do it. And if not, then we will do it. And a very important thing is on the Ultraprobes, what we build, what we provide, what we sell, let's say it like that, we have 5 years of warranty on the equipment. So if something is wrong, don't hesitate just to knock on the door and say, hey, Peter, there's something wrong. Can you look at it? And we'll fix it for you. All right, so the ultrasound technology is, well, easy to use And maybe you think when you have the instrument in your hand for the first time, ooh, there's a lot of functions. Ooh, there's a lot of possibilities. But you would be surprised how fast you will learn. The learning curve for using ultrasound is really short. Even with a 15,000, what I'm going to talk about in one day, you can already do lots of things with the device. It's versatile. And what does that mean? That means one device can cover lots of applications. And applications, I mean, for example, leak detection, bearing inspection, hydraulics, electric, steam traps, vacuum, uh, lots of possibilities with just one device. And if you look at it, cost effective, no more wasted energy or costly downtime. So if you use ultrasound to find the leaks in your facility and you fix those leaks, you would be surprised how much you can save yearly based. And of course, the downtime that's got to do with predictive maintenance. Start collecting data from your rotating assets, follow the trend, and see if the condition of a bearing is going down. So you're always on time to replace the bearing before you have a shutdown, a downtime. Okay, so what do we have? Of course, there are two pictures, but I want to explain briefly the difference. On the right side, you see an Ultraprobe, like the Ultraprobe 15,000. We have them in different variations. But with that one, you can do leak detection, you can do bearing inspection, you can do steam traps, valves. On the left side, it's an ultrasonic camera. And with that camera, and that's a nice thing to see and to have, you can see a leak. You can see a vacuum leak, you can see a gas leak. So for leak detection, that could be a, well, I would not say game changer, but it would be really handy and easy to use to find leaks. All right, so before I'm going to start explaining the Ultraprobe 15,000, I want to go through a few applications, what you can do with it. They're a short presentation, but I think it's important that you have a better understanding on how it works or what's possible. So you see here several parts. You see ultrasonic leak detection. You see condition-based lubrication. You see bearing condition. You see steam trap and valve inspection. Partial discharge detection. So here already you see 5 applications or possibilities what you can do with just one device. So when you think about purchasing an instrument, why not look at several applications if you have them in your facility? So just to start with the first one, ultrasonic leak detection. So leak detection, there are several possibilities. You can do that with a camera, you can do that with an Ultraprobe here, and on the background you see already grayed out the Ultraprobe 15,000 Reimagined. Don't underestimate leak detection. You see, it's the low-hanging fruit regarding energy savings. You never thought about it, or maybe you did, but average a leak in your facility based on 24/7, easily 3 to 5 to 700 euros a year, which you just lose on energy. So if you have a huge facility with 100, 200, 300 leaks, well, you do the math. So it's absolutely a good step to start with ultrasound in your facility. Find those leaks and fix them. All right, so why should we do leak detection? Well, first of all, economics, what I said, costs a lot of money, but also the environment. The more power we use, the more CO2 basically is put into the air by the power plants. So your greenhouse gas emissions. And now in these days, we need to do something about the environment. We need to reduce CO2, NO2 output. So leak detection is absolutely helpful. It's a little step, but it absolutely will help for your environment. And also safety, explosions, implosions, leaks at gas systems, for example. So those 3 parts is what you can use to do leak inspection. Of course, economics is a big one, but don't forget the other ones. Safety, you don't want something to go wrong when somebody's around it. All right, so conclusion, and I already said I keep it short, but I just want to inform you about the possibilities. When it comes for implementing a leak detection program, the most important thing to understand is that compressed air is not free. Nowadays, it's one of the costliest utilities. And I don't want to say that an air leak, although you think, oh, but it's only 500 euros, is very costly. It's also how compressed air is being produced. Approximately 10% of the energy that you put in a compressor to produce compressed air is effective air. So 90% is lost on heat, friction, on other things just to produce air. So the 10% that we already produce, well, I think it's smart to save the leaks by fixing them and finding them, of course. And that's what I want to say. Okay. So another very important part, also when it comes for energy savings, is your steam system. All right, there are some modern boilers that are electrical heated, but the classic ones, the most, well, I think active ones we have in the factory are with gas, the steam boilers with gas. So electricity and gas are very expensive utilities at this moment. So when it comes for steam inspection, you have your steam valves. And what's even more important, you have your steam traps. And for the people that do not know what a steam trap is, it's basically a similar type of valve, but it operates by itself with the difference of steam and condensate. So it traps the condensate, it removes it quickly, and it closes again. So it keeps the steam in the line. So you have an effective steam system. But of course, if you have leaking steam traps and you just, well, remove the condensate, but also the steam, it's very costly. There are steam traps, and they made calculations that they were losing steam for around 30 to 50,000 euros a year on steam. So you can imagine if you have several steam traps, how much money that will cost if you don't check them so now and then and just fix them. Okay, so I have lots of case studies, but this was just an example, a thermodynamic. Basically, it's an on-off steam trap, so it should close, trap the condensate, and it should open. And the customer in this situation did not have lots of experience. Of course, we teach them how the sound pattern should be, but what he did, he had 3 similar steam traps and he took 3 sound recordings. I'm going to play all 3, and basically when you see the spectrum, you know already that the first one is a good one. Now it's closed. And now it opens. So you really hear that quiet, 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 and then so when you have this one and you take sound recordings from other ones, like this one, so although you think it's an on-off design, you see already that this one is doing it way more than it should. And then the third one, and you can already see it at the spectrum. So even without playing the sound file, you already have an idea of what's going on with this one. So there's continuously sound. So that means it's not sealing properly, it's leaking. Not effective at all. So even when you don't have a lot of background information, by doing comparison method, and then of course with the same type of steam trap, you can quickly get an overview from what's going on. So also the conclusion when it comes to steam, together with compressed air, steam is a very expensive utility to produce. Don't think, but start doing your inspections today. And guys or girls, depending on who's attending this webinar, it's really important that you do your inspections. All right. So now we have 2 more what I want to talk about quickly. You see condition-based lubrication, and the other one is bearing condition monitoring. So condition-based lubrication is basically an addition on your existing lubrication program. So what can we do? Well, first of all, there are a few ways in which lubrication programs are executed. And a very familiar one, so that we all know, and I think in 80% of the factories this is happening, time-based predictive maintenance. This time-based means after so many hours, we need to lubricate so much grams, milligrams into this specific bearing. So it's a guideline that we're following. But since there's so many variables in the factory, you never know for 100% sure if you really need to, well, grease or not. So when we do time-based assisted with ultrasound, so nothing changes basically for the customer or for the factory. You still follow the program, but instead of lubricating every bearing now with the prescription we have of it, now we're gonna listen and see how many shots of grease does that bearing really need or not. And the third step is condition-based lubrication. That means we're going to collect data over time, friction level. If the friction level increases and it reaches a certain alarm level, then we're going to grease that bearing. And that is condition-based lubrication. But then you need to have a plan. You need to have an instrument. You need to have an inspector, and you need to have a grease caddy to determine how much grease really is needed for that specific bearing. Question: when do you know when you have applied enough grease? Answer: I don't know. But when I see it coming out of the side, I think that's enough. How many of you persons, when you think about it, and maybe you're smiling now, well, or not, is that when you grease the bearing, you literally saw the grease pouring out of the seal? So, full, perfect. It's completely overgreased. And the danger is that when you put so much grease into it that you just damage the bearing. So why don't listen to the friction level of a bearing when you grease it? And when the friction level stays stable, you know, this is the moment it reached the ultimate friction level. We need to stop greasing a bearing. So it gives you lots of information. The equipment is trying to tell you something. Okay, so time-based lubrication plants are probably the most common way of performing lubrication on sites because that's what we always did. That is for years like that. But think about taking the next step, right? Using ultrasound. Listen to the quality of the bearing. So when we do that, when we listen, we know eventually the more data we collect, if the interval maybe needs to be extended or maybe needs to be shorter than that we have. So the more measurements we do, the more data we collect, eventually we know, hey, this is the perfect timeline to grease a bearing. Okay, so what you see here, same, we took a sound recording, you see a high intensity sound level, eventually it completely drops. And this is how it sounds like when you listen with ultrasound during lubrication of a bearing. And of course, it goes in slow steps, and eventually the grease has effect, and effect, and effect, and eventually it stays stable. And you hear a huge difference. The nice thing was, when you noticed it, when the bearing needed grease, it was still a uniform rushing sound because the bearing is not damaged, but it needs grease because if we're way too long at that moment, then damage can occur in the bearing. Okay, so with a condition-based maintenance program in place, we can apply our lubrication intervals to the results of the inspections carried out. And that's what you see on the right side here. You see an historical trend. These are time. The green line is the baseline. Yellow is the lubrication. And you saw, hey, this reached the moment we need to grease it, and then we're going to grease it. So condition-based, we know exactly when we need to grease. And here, a nice one. If my baseline is 20 decibels and 3 months later, it's still 20 dB, why should I grease, right? Because the program is telling me to do that. Now, if the friction level is still okay, we don't need grease. Of the bearing does not need grease, but we need to measure it to see what's going on with the condition. Okay, so also here, the conclusion when it comes for lubricating a bearing, lubricating a bearing is not just to add some grease. It's a specialism. And what works better than listening during lubrication? Never too much or too less. Because if we hear what the effect of grease is when it enters the bearing, that gives us so much information. We know exactly what we need to do or what we not need to do. Okay, so, and the other one, bearing condition monitoring. That is, we have an ultraprobe like this one. We measure the bearings and we start collecting data over time. So we're going to build a trend. So the long-term goal is to use technologies in order to identify potential equipment failure. So the more data we collect, eventually we will see that something is going on over time. If the friction level is increasing, we know the condition is changing. Depending on the alarm level, we know in what kind of alarm phase is it. Is it lubrication? Is it beginning visual faults? Or is it really badly damaged? Okay. The PF curve, I think the most of you already knows this one. The point to failure, or the official name is the D to I to P to F, the design installation point to failure. But what we see is that when you look very high on top of the curve, that ultrasound basically is the first technology that discovers, detects a change in condition. So I will not say a fault, no, a change in condition. And the first change in condition of a bearing is friction related to lubrication. So when we detect that on time and we grease the bearing with the correct grease at the correct moment with the correct amount, well, we prolong the lifetime of the bearing. I would say prolong is the right word, but we are trying to achieve the designed lifetime of that specific bearing. Of course, if it's properly aligned, the correct bearing, etc., etc. But lubricating a bearing is more important than you think. Okay, so why could or should we use ultrasound for bearing inspection? And don't get me wrong, guys, there is more than only ultrasound, but I just want to show you the possibilities with ultrasound. So first of all, we measure friction. Friction is no rocket science. A bearing produces friction. When friction increases, something is changing inside the bearing. So we are in the high frequency range, in the 30 kilohertz range. That's where we listen to a bearing. And in that frequency range, changes are very early detected. So when we collect the data on time and we can adapt to the information we have, basically we can prevent downtime or any potential problems in the future. The other hand, to collect data with an Ultraprobe is very easy, and especially with the new one with wireless Bluetooth data, yeah, it goes quicker and easier. Okay, so here you have an Ultraprobe. You have no experience, no background info. You only know a little that a good bearing should have a uniform reversing sound, like this one. If you hear this, this is a school example. This is a perfect bearing. Because the ultrasound is so sensitive, you also do not have to look for something in the sound recording. When there is a fault, you will hear it. All right, this one, similar bearing. Another similar bearing, and you already see it, right? It's more damage. Okay. A similar bearing, and also here you will have a more intrusive sound. And then, of course, this one, and when you look at it, the sound pattern you can expect. Nice uniform rushing sound. Oh, wait, fast. Oh, is my presentation stuck? But if you see the same application screen. Oh, okay. So basically what I showed is not visible on my screen. So, all right. I just see it now. Somebody came in. I'm very sorry. I thought I was presenting the different screens, that they were visible, but it seems that the screen was stuck on the application. I thought I would show the other presentation what I made. Unfortunately, it's not. All right. I'm sorry for that. I did a new because I had several presentations that were there, but they were not visible. Pity. On the other hand, you heard the sound files, and what I just explained is the different types of applications and why they're so important. So I'm really sorry for that. Let's continue. And all right. Okay. I hope you can see my screen. We still don't see. Stop sharing and share again. Okay, one moment. I will stop sharing. Oh, no, now it works. Okay. So yeah, that's the thing. If you do it real life, it's always something can happen. Okay, so this is the Ultraprobe 15,000 reimagined. I don't know if there are people that are using the former model. It looks a little the same, but this one have had some upgrades, and that's what I want to explain now to all of you. So you already see it. It has a different color, bigger camera, same battery, same case, but it has some improvements to make the inspections for future easier. Okay, so first of all, it's faster and more powerful. It has some adjustments internally, but also on the outside to make the inspections, well, more precise, more informative. And you already see enhanced processing capabilities, a high resolution camera, Wi-Fi enabled data synchronization. So we don't need to work with an SD card anymore. We can just synchronize the data, what we want to have, upload that route, and we go and we're ready to go. There's a faster processor in there. The instrument is a little lighter, but what you do see is there is still a possibility for an SD card if needed, but it has wireless data transfer. Okay, so the first thing, a high power processor, that is to process the data, the sound recordings, what we collect, the photos, what we take. It goes quicker. So the sound data is faster being stored or being transferred. There's still a laser pointer on there. There's still a temperature sensor on there. There's still a strobe light on there to measure the RPM. The touchscreen works very fine, very nice touchscreen. And when you look at it and you see, you recognize something. It's the same display principle as with the 15, but faster and easier to use. Okay. High power processor. That is what I said about the sound spectrums. When you take a sound recording of a minute, it saves it really quickly. What we can, well, basically upload with wireless data transfer to the DMS, and then we're ready to go to the analysis. Okay, so the Wi-Fi, this is something new what we have. In the beginning, we did it with a cable, we did it with an SD card, and now you just go sit in front of your computer, you connect to your local network, you see the DMS, you can scroll through all the routes. So you select the route what you want to upload, it's in the instrument, and you're set to go to collect the data. So it's much quicker and easier. You don't have to carry around lots of several SD cards. You just select the route that you want and you're up to go. Okay, so the Bluetooth, like my headphones, is also something what is improved. The 15,000 has already Bluetooth, but this one has a faster Bluetooth processor that makes it easier to connect to Bluetooth, but also the sound is almost, well, it is one-on-one. So what you measure is what you hear. So it's more stable than we had. Okay. So high resolution camera. The camera used to have 2 megapixel. Now it has a 5 megapixel camera, so you can do really high resolution photos, what you can use later for your reporting in your Excel, in your Word, or maybe through DMS. And also, it's a little lighter. You also saw that the design is shorter, like we push it a little in each other, but that also makes it easier to use. The old model was also not that heavy. This one is a little lighter, so it's even easier to do it when you have to do longer inspections. And the last one, it's future-proofed. And what does that mean? Because we have a high resolution camera on there, we have a fast processor. The processor is fast faster than basically what it needs to do. But on the other hand, developments are always there. Future developments are there. Our R&D team is already working on those future-proof things. So, for example, what we could do is QR code scanning. That is something what we get asked a lot. So we're already looking at that, how we can embed that in this tool, because it's future-proofed. It's not at the end of its development. It's the beginning of its development. So the things we have now, the better Bluetooth connector, the Wi-Fi connection, that's already a nice step. But this one is just standing on the beginning from what it eventually all can do with the artificial intelligence. So it's a nice device to have. And how can we do that? Well, basically, when there is firmware, when the instrument is calibrated, it will automatically be updated, and then you have the new abilities on the Ultraprobe ready to use. Okay, so in a short, brief overview, what can we do with the Ultraprobe 15,000? Compressed gas, faster data transfer, vacuum, slow speed, steam traps, electrical inspection, monitoring bearing health, a high resolution camera, internal leaking valves, compressed air, hydraulics, strong Bluetooth, Wi-Fi data transfer, electrical inspection. And to be honest, I think maybe I forgot already a few things, but this is what it can do. And it makes your inspection easier. You can use it for your leak detection. You can use it for your bearing inspection. It's a low learning curve. So everybody can start working with this device. And besides ultrasound, don't forget vibration. Don't forget oil analysis. Don't forget infrared. Those are all strong technologies, but eventually will help your factory to have a reliable and safe plant. So once again, I'm really sorry that you didn't saw the other presentations, what I especially made to explain a little better about slow speed, lubrication, bearing inspections, leak detections. In case you want to have this presentation, I can share it with you, so you still have all the information what I was trying to show you. It's really a pity that, well, the presentations were not visible. I thought I was sharing the screen all the time, but it seems that it is only this presentation what I was sharing. So once again, I'm really sorry. If you want to have more information regarding the 15,000, don't hesitate, just contact UE Systems or contact me. This video will also be uploaded to YouTube, that you can always look it back. So once again, this was the presentation about the 15,000 Reimagined and of course its applications. In case you have any questions, don't hesitate, just put them in the Q&A, and otherwise I will see you next time on a different webinar, what I'm going to present. Thank you and see you next time.